Ever wonder how those complex gadgets in your pocket go from just a wild idea to an actual working device? Well, today we're going to pull back the curtain on modern circuit design. We're talking about a world where you can build, test, and completely perfect a system all in software before a single piece of hardware is ever made. So let's get right to it. It really wasn't that long ago that designing a new electronic circuit was, well, it was kind of like trying to find your way in the dark. Engineers needed this incredibly deep knowledge of how every little component worked, plus some seriously complex math, just to even get started. And this slide just lays it all out, doesn't it? The old way, you were literally drawing on paper, then you'd have to painstakingly build these physical prototypes, and then it was just endless trial and error. So slow, so expensive, and honestly, you needed a ton of imagination just to guess what was happening inside the circuit. But now, wow, we've got this digital, interactive, and just amazingly efficient way of doing things. So what was the big game changer? Well, it's something called electronic computer-aided design, or ECAD for short. And we're going to be looking at one of the real heavyweights in this space, Proteus Virtual System Modeling, or VSM. Think of it as a complete software suite that lets you design and test your entire project, all right there on your computer. Yeah, and this quote from the source material just nails it. It says, "Interactive circuit simulation now makes the job of analyzing and designing electronic circuits quicker, easier, therefore cheaper, and more fun." And that last word is key. It's not just about being more efficient. It actually makes the whole process more creative, and let's be honest, a lot more fun. Okay, so Proteus is basically built around two main programs that work together. On the left, you've got ISIS. That's your digital drawing board. It's where you dream up and simulate the circuit schematic. Then, on the right, you have ARIS. ARIS is the one that takes your perfected design and turns it into the actual blueprint for the physical printed circuit board, or PCB. All right, so how does this all actually work? It all kicks off with capturing your circuit idea digitally inside ISIS. Let's walk through it. The whole process is actually pretty straightforward. It boils down to 3 simple steps. First, you pick your parts. Second, you draw the connections between them. And third, if you're building something smart, you give it a brain by attaching your code. And when it comes to picking parts, you're definitely not limited. Proteus has this massive digital library of components. It's like a giant virtual warehouse. Everything from the most basic resistor all the way up to complex microcontrollers, it's all right there, just a click away. So once you've picked your parts, you just drop them onto this virtual canvas and draw wires to connect everything up. It's almost like digital connect the dots for electronics. And what you end up with is a professional standard circuit diagram, just like this one. Okay, now this is where the real magic happens. If your design has a microcontroller, the brains of the whole operation, you just open up its properties and tell it where to find your program code. That's it. This is the exact moment your virtual hardware comes to life and gets its intelligence. All right, so we've designed the circuit, we've loaded up the code. Now we get to what is, for my money, the most powerful part of this whole thing, the virtual test bench. This is where we find out if our idea is brilliant or if it's back to the drawing board. This is it, the big question, right? Does it actually work? This is the kind of question that used to take weeks and a lot of soldering to figure out. But in the world of simulation, we get our answer in seconds. And check this out. You literally just hit the play button and the whole simulation springs to life. What you're looking at is the source code debugger. This means you can pause everything, go through your program one line at a time, and watch the chip's internal registers change right before your eyes. It is exactly like having X-ray vision into the brain of your microcontroller. But hey, it's not all about the code, right? What about the actual electronics, the signals? Well, this is where the virtual lab bench comes into play. You get a whole suite of virtual test equipment that you can just drag and drop right onto your circuit. So let's say you need to check out a signal. No problem. You just grab a virtual oscilloscope, attach its probes to any wire in your circuit, and boom, you get a real-time waveform display. It's exactly like using a real piece of gear that would normally set you back thousands of dollars. And what if you're dealing with something more complex, like a whole bunch of data lines talking at once? Well, that's what the Virtual Logic Analyzer is for. It lets you capture and look at all those digital signals together, which makes debugging communication between chips an absolute breeze. You can actually see the data flowing. Okay, so you've done it. You designed it, you tested it, you squashed all the bugs, and you know for a fact that it works perfectly. So what's next? Well, now it's time to take this proven virtual design and turn it into a real physical thing. And the magic that makes this happen is a little something called a netlist. It sounds complicated, but it's not. When you're happy with your schematic, the software automatically creates this file. It's basically just a list of every part and every wire, and it acts as the digital bridge between your drawing and the physical circuit board. And this is that bridge in action right here. You take that netlist from ISIS, that's our verified schematic on the left, and you import it straight into Eris. Eris then uses that exact information to help you lay out the physical copper tracks for the final PCB you see on the right. And the best part? It completely gets rid of any chance of making a mistake when you transfer the design. So let's just step back and look at the whole picture here. You get to design your entire circuit on screen. You test and debug everything interactively before you build a thing. You can analyze its performance with a whole virtual lab bench, and then you automatically generate the layout for your PCB. The bottom line, you save a massive amount of time, money, and let's be real, a whole lot of frustration. Look, this kind of technology really changes the game. It completely lowers the barrier for innovation. It means pretty much anyone with a good idea can design it, test it, and perfect it in a totally virtual space. So it really leaves just one question, doesn't it? Now that you can test any idea before it's real, what will you build?